Picture this. A sleek humanoid robot strides confidently into your kitchen, moves with calm precision, and starts whipping up a mouth-watering breakfast entirely on its own. Eggs sizzle to the perfect texture, bacon crisps to a golden finish, and every motion looks deliberate, careful, and almost human. This is the promise of Tesla Bot Gen 3, a machine turning what once seemed like pure science fiction into a real, working demonstration of artificial intelligence and robotics in the most human of spaces, the home kitchen. This moment is far more than a flashy tech demo. It represents a psychological turning point for humanity. For the first time, a general-purpose humanoid robot is stepping out of controlled factory lines and into an environment built entirely for people, not machines. The kitchen is unpredictable, cluttered, and unforgiving, a place of hot surfaces, fragile objects, slippery floors, and constant change. If a robot can survive and thrive there, it suggests that the boundary between human-only tasks and robot-capable tasks is dissolving at incredible speed. What makes Tesla Bot Gen 3 especially impressive is how it approaches cooking not as a rigid checklist of actions, but as a fluid, sensory challenge demanding coordination, timing, and judgment. To prepare something as simple as bacon and eggs, it has to locate and open the refrigerator door correctly, visually recognize eggs, meat, oil, pans, and utensils, and pick them up with just the right amount of force. Too much pressure, and the egg shatters in its grip. Too little, and it slips and falls. The robot then has to turn on the stove safely, control the heat, crack the eggs cleanly into the pan, add oil in a measured way, move ingredients around for even cooking, and finally plate the dish in a way that looks presentable and appetizing. Every one of these small steps hides a complex fusion of hardware and software working together. The hands must be dexterous enough to perform delicate manipulations usually reserved for humans, with multiple joints and actuators mimicking tendons and muscles. The vision system must be sharp enough to distinguish similar-looking items, a white egg on a white countertop, for example, and track them while in motion. The control system must continuously adjust balance and posture as the robot reaches, turns, and steps around the kitchen, making sure it does not trip, collide, or knock things over. All of this has to happen almost instantly, in real time, without a human behind the scenes pulling the strings. This is where Tesla's earlier generations of the robot, from the Bumblebee prototype to Gen 1, Gen 2, and Gen 2.5, set the stage but never fully solved the problem. Those versions showed walking, lifting, and simple repetitive motions, often under teleoperation, where a human secretly guided the robot's actions. The yellow and black bots people saw online with updated arms are still from those transitional stages, not the final Gen 3. The true Gen 3, according to Tesla's current roadmap, is positioned as the first version intended for fully autonomous real-world use rather than just experimental testing. It is meant to behave less like a remote-controlled mannequin and more like a genuinely independent worker that can be trusted around people, pets, and everyday objects. The leap in capability between Gen 2.5 and Gen 3 is enormous. Earlier versions relied heavily on scripted sequences and human intervention, and they were known to stumble or fall during demonstrations. Gen 3, by contrast, is designed to carry out up to around 100 open-ended tasks in a day, adapting its behavior based on what it sees and experiences. Tesla's engineers have reportedly expanded its internal skill library from a few hundred predefined actions to thousands, enabling it to combine those actions in flexible ways: reaching, grasping, turning, stirring, cleaning, sorting, and more. This is one reason Elon Musk has spoken with such confidence, even surprise, about what the robot is now capable of in practice. A major reason cooking is such a powerful demonstration is that it exposes all the weaknesses that plague most other humanoid robots. Many companies can produce machines that can walk, run, jump, or perform athletic tricks that look impressive in a choreographed video. However, when those same platforms are asked to do something as ordinary as peeling an orange, washing vegetables under a faucet, or assembling a sandwich, their limitations become painfully obvious. They lack the fine motor control, real-time reasoning, and robust perception needed to handle soft, irregular, and fragile objects. By showing Tesla Bot Gen 3 handling a real meal from start to finish, Tesla is signaling that Optimus is aimed at everyday usefulness, not just viral clips. Under the surface, Tesla Bot Gen 3 benefits from a deep integration of hardware and artificial intelligence that draws directly from Tesla's experience with electric vehicles and autonomous driving. The same kind of custom AI chips, battery systems, and vision-based neural networks developed for cars are being repurposed into a humanoid form factor. Musk has often described Tesla vehicles as robots on wheels, and in that sense, Optimus is the logical extension. A robot with arms, legs, and hands instead of wheels, but powered by the same philosophy of using vision, neural nets, and end-to-end learning rather than rigid rule-based programming. One of the most remarkable aspects of the Gen 3 design is the focus on the hands. The human hand is an evolutionary masterpiece, with more than 24 degrees of freedom and a complex structure of muscles and tendons enabling both force and finesse. Recreating even a fraction of that capability in a robot is extraordinarily difficult. Tesla's approach is to build hands with many joints and actuators, giving the robot fingers that can curl, pinch, twist, and rotate in a coordinated way. With that mechanical foundation, the AI can then learn gripping strategies from human demonstrations, video footage, and simulated practice. Over time, the robot becomes more confident in handling everything from a frying pan to a delicate glass cup. The robot's brain builds on this mechanical platform by learning directly from the world. Instead of being painstakingly programmed step by step, Optimus Gen 3 can observe humans performing tasks by watching real-world recordings or structured instructional videos. The underlying AI then translates those observations into internal motion plans, running them millions or even billions of times in a virtual environment. In that simulated training ground, it refines trajectories, corrects mistakes, and identifies efficient strategies. Only after it reaches a high level of reliability does it attempt the same task in the real kitchen. This approach dramatically accelerates learning and allows the robot to acquire new skills at a pace that would be impossible through manual coding alone. For now, the image that captures this transformation best is simple: a robot in a kitchen, quietly preparing a meal. The act feels familiar, even intimate, yet the performer is not human. It is a carefully engineered blend of metal, plastic, code, and electricity, executing a routine that many people repeat every morning without much thought. By conquering that routine, Tesla Bot Gen 3 sends a clear message. Humanoid robots are no longer confined to lab floors and promotional videos. They are beginning to step into the spaces where human life actually happens, and they are learning fast.